Hello, 6th graders. Welcome to Big Ideas Math, Section 1.2, Powers and Exponents lesson. Pause while you write Section 1.2 lesson in your math notebook. Pause while you write the lesson objective. I will be able to use repeated factors in real-life situations by writing and finding values of powers. Today we're working on page 12 in our textbook, so you'll need to be sure and take careful notes in your math notebook. You've already written down today's vocabulary and definitions in your math notebook, but let's review. A power is a product of repeated factors. The base of a power is the repeated factor. The exponent of a power indicates the number of times the base is used as a factor. So the diagram they have in the textbook shows you the power is the whole thing. It's the base and the exponent put together. 3 is used as a factor 4 times. So 3 is the base, 4 is the exponent. So you multiply 3 by itself 4 times. Remember that the dot is sometimes used as a multiplication sign. Here's a nice table that tells you the words that go with powers. So 3 to the second power is sometimes called 3 squared. And 3 to the third power is sometimes called 3 cubed. And 3 to the fourth power is called 3 to the fourth. Take some time, pause the slideshow, and copy this table in your notes. So the first thing we're going to be doing in this lesson is we're going to be writing expressions as powers. So our first expression is 4 times 4 times 4 times 4 times 4. So if you were counting as I read that, you would have noticed that I said 4 5 times. So because 4 is used as a factor 5 times, its exponent is 5. So 4 times 4 times 4 times 4 times 4 equals 4 to the 5th, or 4 to the 5th power. And let's look at example 1b. 12 times 12 times 12. 12 is the base because 12 is used as a factor 3 times. 3 is the exponent. Its exponent is 3. So 12 times 12 times 12 equals 12 to the third power. So that's how we write that. So start thinking in those terms. 4 is the base, 5 is the exponent, 12 is the base, 3 is the exponent. Let's take a look at the math practice box. It says choose tools. Why are calculators more efficient when finding the values of expressions involving exponents? I think we can all answer that. It's easier to press a button lots and lots of times than it is to multiply things out longhand. However, you should have the skills to do that if necessary. Let's look at example 2. Our next skill that we're learning is finding values of powers. So now that we know how to write them, we need to find the values of them. So we have 7 to the second, or 7 squared, and instead of going one direction, we're now taking it apart going the other direction. 7 squared equals 7 times 7, and it's a basic math fact. 7 times 7 equals 49. And our second example, letter B, we write it as repeated multiplication. 5 times 5 times 5. 5 times 5 equals 25. 25 times 5 equals 125. The thing we don't ever do is multiply the base times the exponent. That's a common error, and that's something we never ever want to do. If you need to take some notes on this page and write some things down from this page, pause while you do that in your math notebook. Our next skill in example 3 talks about perfect squares. At the top of the page, it tells us that the square of a whole number is a perfect square. So if we take any number, say 2, and we square it, so we multiply it by itself, 2 times 2 equals 4, then that product, 4, is a perfect square. So let's look at our example. Identifying perfect squares. Determine whether each number is a perfect square. And example A says 64. Because 8 squared equals 64, then 64 is a perfect square. So since there's a number that multiplies by itself to get 64, then 64 is a perfect square. And then if we look at B, 20, there is no whole number that multiplies together to equal 20. So 20 is not a perfect square. In this exercise, you really need to know your basic math facts in order to know if things are perfect squares or not. So this is one of those skills where if you don't know your math facts, you're going to need to brush up on those. Let's skip down the page to where it says the area of a square is equal to its side length squared. Here it's asking us to remember that the area of a figure is the amount of surface it covers. Area is measured in square units. So looking at the square that they've given us, the area of a square is equal to its side length squared. Area is 3 squared, and so the area of our square here is 9 square units because you can fit 9 squares onto this big square. So our real-life application is a Monopoly game board is a square with a side length of 20 inches. What is the area of the game board? It says in the book to use a verbal model to solve the problem. A verbal model is simply an equation. It states in words the formula or process that will be used to solve the problem. So how do we find the area of a square? Well, we find the area of a square by taking the side length and squaring it, so multiplying it by itself. So we know that 20 is the side length because it tells us that in our problem, 20 inches. And so we take 20 times itself, 20 times 20 times 20. And I'm going to write that here so that you recognize it. And 2 times 2 is 4. And then there's 2 zeros on the end, so it equals 400. So the area of the game board is 400 square inches. Remember to put your square in there when you're doing this on your own. Remember, to earn credit for viewing this flipped lesson, you need to complete your notes in your interactive student notebook, complete your on-your-own questions in your interactive student notebook and submit them in your Google form, and complete your Big Ideas math assignment in your math notebook and submit it when it is 100% correct. Remember to visit your teacher if you have any questions.